Imagine this, your company's revenue dashboard suddenly changes overnight. Finance team is confused. Management keep asking the questions. And you are the data engineer who is responsible for this. But instead of panicking, you just rewind the data to yesterday and check what exactly happened and then fix it and optimize the performances. Clean all unnecessary files all in minutes. That's the power of Delta Lake. In today's video, I will explain the advanced Delta Lake features like time travel, merge operator, optimize, Z-order, and vacuum. And we will implement everything step by step in Databricks. By the end of this video, you will confidently understand what is time travel, why we use time travel, and what is optimize and Z-order, and what is merge operator, and what is vacuum. So without wasting any time, let's get started. Let me start with a story. Imagine this, you're working as a data analyst or data engineer in a big e commerce company. Every day, thousands of orders are placed, some orders get cancelled, and some orders get updated. Data keeps changing every time. Your Delta Lake is the super digital warehouse. As business grows, new challenges will appear. So let's solve one by one. Story. One morning, your manager says, Ravi, yesterday our revenue was 1 million, but today it shows 1.2 million. What changed? So instead of guessing, you rewind the data. Delta Lake keeps a version of history of your data. It's like a CCTV footage. You can go back any of your previous version. That's where we will use time travel. Let's go to our Databricks user interface. There we will implement this time travel in our e-commerce dataset. So as you can see here, so I am in the Databricks user interface. Here I have already created the notebook. If you don't know about how to create a new notebook, you can go and check my previous video. There I have explained in detail. So here this is our day 5, and in this day 5 I have created the folder name as well, day 5 advanced Delta Lake. And I already read the data which is stored in my Rocky folder. So as you can see here, the data set I have imported, that was order items data set. So I have read the CSV file, and here if you can see, like header is called true means my data has a header column, and info schema is true means my data has following the schema rules. And I have displayed the order items table, and you can see here this is my order items table. So in this table, if you can see the price, so the price and the freight value. So every order has the price value and the freight value. First, what we can do, we can add both of them, because once we add price value and the freight value, like courier price, then we will get the total value of the each order value. So let's get started. So what we can do, we can just simply take the AI assistant help. Here you can just write create a. So here what we are going to do, we are going to connect, like we are going to create a new column in our order items table. Like we will add price value as well as freight value, so that we will get the total value of the each order. So how we can do that? First, what we can take the help of the AI. We can just write the prompt, create a column to add price and freight. So now what we are going to, we are going to create a new table which is add the price value as well as freight value, so that we will get the total value of each order ID. Here I have write already a prompt, like create a column to add price and freight value, and just click on generate. So it will give you the code, then we can easily run that code. And now you can see, we can just click on run suggested, and it will give you the output. And if you can see here, let me just check. Here you can see the total value, so price value and freight value added, and it gives the total value. So we can simply accept this. So now we need to check the time travel. We need to check the what changes we have did. For that, what we are going to do, so we know very well, like, so we have what we have did right now. We have add the price column and the freight value column to get the total value. Now we are going to check with the help of version history, with the help of time travel. By using time travel option, we can check what the changes that we have did. So for that, first what we are going to, we are going to store our data into the delta table. You know very well, delta table is a digital warehouse where we can store our data so that we can get easily access. Here what I'm going to do, I'm going to store my order items table in the to create the delta table. So this is the code for creating a delta table. So I'm going to run this code and it will successfully create the delta table. As you can see here, it is, and now you can see it is successfully created the delta table. And then in the next step what we are going to do, we are going to create the delta table, how we can create the delta table in SQL. So here this is the code to create the delta table in SQL. So SQL dot create table if not exist, like I need to change the name, order items delta. Now you can see here we have successfully created the delta table. The code is for this, create the table if not exist, order items delta, this is a table name if not exists this name, and then the data I'm going to store from select star from the order items delta. So this table I'm going to store in the SQL. So now you can see there is number of affected rows is 0, number of inserted rows is equal to 0. So we have successfully created the delta table in SQL. If you want to check the table, you can just simply use this code, select star from order items delta, just click on run this code, then you will get the table as you can see here. So this is the table which you have stored in your delta table in the SQL. Okay, and now this is the time to update something else. What we are going to do, we are going to take any order ID, and with that order ID we are going to change the value so that we will see in upcoming like what is the time travel usage. So some people will change the values of the price value or any other values, then we can easily identify which person is changed this thing and what was the time he has changed and what change he has did with the help of time travel. So let's just check. So here, so you can see I'm going to update the order items. So what I'm going to do, I'm going to change the one order ID price value. So let me just take this first order ID and just I'm going to update this order ID. I will just take and copy paste, and then so total value. So here total value, update the table name and set total value is equals to total value plus 100, and just simply run this code and you will see here number of affected rows 1. So we have updated one order ID with add the 100 rupees, with add the 100 rupees on that. So if you want to check before the this order ID value is, if you can see first order ID value is 72.19. If you can check that same order ID value, what was the same order ID value now. So now what we are going to do, we are going to check all the changes that we have did. Let me just check all the changes that we have did with the help of describe history and the order table name. So as you can see here, so in the version of 0 we have created a table. The next one is we update the like one order ID, you can see here. So we have easily check here, you can see. So first we have created the table, then we have updated the order ID with the price value. So this is how we can use. Now you can see that we have changed, like for in the version of 0 we have created, first what we have did, we have created the table in SQL. Then what we have did, we have updated the one order ID value to add the 100 rupees extra. So that changes was also here, and you can see the user ID and the timestamp, what exactly time that the change was happened, and username was me, this was my email ID. So this is how we can use time travel to check what the changes happened in the previous. So it's like a CCTV footage for your data. So now what I'm going to do, I have just write the prompt. What the prompt that I have by using merge operator, merge the order items table with the order items new orders table in SQL. So the Databricks AI assistant give you this prompt and you can just simply run this suggested one before accepting the code, and you can see it is successfully loading the data, and you can see number of affected rows and updated rows are 6. So the rows are updated. So the order ID which we are having, those order IDs are matched with the existing order items table, and that's why it was updated the values. And number of deleted rows are 0 means we haven't deleted any rows, and number of inserted rows are 0 means we haven't inserted a new rows, because new data we don't have any new order ID, so that's why it showing 0. So that's how we can use merge operator in Databricks. So in simple words, if I will tell you, for example, in your e-commerce company, every hour orders are placed. So new orders will become, and also existing order IDs will also become. So what we can do, we can use merge operator. If the new orders will come, first, what the Databricks can do, it can check the label, like order ID or the label of the table. If the label will be matched, then it updates the data. If label will doesn't match, then it insert all the data. So that's the power of merge operator that we can use in Databricks. Now let's just understand optimize and ZORDER. So after months of data loading, your warehouse is messy. All small files are stored in your warehouse, so queries become slow, and if you want to fetch the data, it harder to, it takes more time to fetch the particular data. So in what you can do for that, you can use optimize. So in short, optimize means it can concat all the small files into the bigger one, so that you can easily fetch the data which is required. So that's how we can use optimize. So ZORDER we can use to arrange the items based upon the category to fast search by using ZORDER. So we are simply going to optimize the table first. So as you can see, we have optimized the table here, optimize and order items table in the table name, and ZORDER by order ID. Based upon the order ID, we arrange the order. And now if we can just run this code, and now you can see the code was executed successfully. So as you can see here, the path. So this means we have successfully optimized the order items delta table, and we order the data based upon the order ID by using ZORDER. So that's how we can use optimize and ZORDER in Databricks. And the next one is vacuum. Let's just understand vacuum operator with a little story. Delta Lake keeps the old versions for time travel. So after a couple of months or couple of years later, so all the data was stored, old data. So it becomes too hard to store the data in Databricks, because it requires storage. We don't need old data. So what we can do, instead of storing all the data to become our Databricks slower or warehouse slower, what we can do, we can use vacuum operator to clean all the old files. That's where we can use vacuum. So let's just do the practical way. So how we can use the vacuum in SQL, you can just write only vacuum and order items table, and just here retain like 1 hour or 2 hours or 60 hours or 1 month. You can just write here. Here you can see vacuum order items delta, vacuum and the table name, and retain 1 hour. So like past 1 hour data will be deleted. If you want to write 168 hours, so it means 7 days. So you will delete the 7 days data, past 7 days data. Last 1 hour data, I'm going to delete all the last 1 hour data. I'm just going to run this code here. And as you can see here, so the last 1 hour data we have successfully deleted. So this is how we can use VAC to clear our storage. So in this video that we have learned four things. One is time travel. If you want to see your past data, what the changes that you have did in the past, so you can use time travel. And the second one is merge operator. So the merge operator, if you we can use upsets. For example, if the new order will come, if the order ID is matched with the existing table, then it updates the data. If order ID is doesn't match with the existing table, it inserts the data. That's how we can use merge operator. And the third one is optimize and ZORDER. Why we use this? Because our warehouse stores small files. So what we can do, we can concat all the small files into bigger one to search faster for the particular data. And we can order the data based by using ZORDER. And the vacuum. Fourth one is vacuum. Why we use vacuum? Vacuum is to clean your past data to prevent the storage. So that's it for this video, guys. I hope you learned something out of this video. Till then, keep learning and keep exploring. I will see you in the next video, which is day 6. Thank you so much.